Hi, I am Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video, we are going to see about general feedback structure. First, let's see about Introduction to Stability. Stability is an important concept in operational amplifier circuits and other negative feedback amplifiers. Due to phase shift, negative feedback may change into positive feedback. So, positive feedback can increase the output signal continuously and make the circuit unstable. A stable amplifier does not oscillate and does not go into saturation due to unintended positive feedback. So next let's see why this stability is important. So when an amplifier becomes unstable, even a small input signal can grow uncontrollably. This causes distortion, oscillations, or complete failure of the circuit. Therefore, stability analysis is necessary to ensure proper amplifier operation. So next let's see the important feedback system parameters. A feedback amplifier is described using three parameters. These are the open loop frequency response represented by letter A, the closed loop frequency response represented by GCL, and the feedback factor represented by beta. So these are the three important parameters in feedback system. So next let's see about frequency response representation. So commonly Bode plots are used to represent open loop and closed loop frequency responses. Bode plots are also useful for representing frequency dependent feedback networks. If the feedback network is purely resistive, then the feedback factor beta is a constant value. Next, let's see about effect of poles on stability. An amplifier with 3 or more poles can produce a phase shift greater than 180 degrees. The frequency at which the phase shift becomes exactly 180 degree is called F180. Next, the fundamental stability condition. So for an amplifier to be stable, the magnitude of the loop gain must be less than 1 and at the frequency 180. If this condition is not satisfied, then the amplifier becomes unstable. So next is the practical stability requirement. So for reliable and robust operation, the loop gain at F180 should be much less than unity. This ensures good circuit performance and it avoids marginal stability. Next is Nyquist plot overview. So the Nyquist plot is one of the graphical tools that provides clear information about amplifier stability. It shows both magnitude and phase behavior of the loop gain in a single plot. So next is quantity plotted in Nyquist diagram. In the stability analysis, the Nyquist plot represents only the loop gain A beta. Open loop gain and closed loop gain are not used directly for Nyquist stability analysis. So any one of the loop gain is used for analyzing stability. Advantages of Nyquist plot are it does not provide the numerical value of F180. However, this is not required for stability analysis. The plot directly shows the magnitude and phase information needed to check stability condition. Next is an important point called as critical point -1, 0 on the Nyquist plot. Actually, this point -1, 0 on the Nyquist plot represents unity loop gain with exactly 180 degree phase shift. This point is used as a reference point for determining stability. So next let's see about how an amplifier is said to be stable or unstable. If the Nyquist curve crosses the negative real axis to the left of the point -1, 0, then the loop gain magnitude is greater than 1 and the amplifier is said to be unstable. If the curve crosses the point -1, 0 to the right, then the loop gain is less than 1 and the amplifier is in stable condition. Next is gain margin concept. So stability is not only about whether the circuit is stable or unstable, but it is also about how the stable circuit is. This is measured using gain margin. So gain margin is a parameter which tells us how much the circuit is in stable condition. So amplifier stability depends mainly on loop gain, and the condition for stability is that loop gain must be less than unity at 180-degree phase shift. And the Nyquist plot provides a simple and effective method to analyze the stability and also the gain margin. Thank you.